Hi everyone, welcome back. It's been a while since we've done any notes. We're going to start our trig unit now. I'm not going to lie, these notes are going to take a little while, but it's really important that you guys follow through and listen. I know it's hard to be motivated to do this, but especially the trig, you're going to use it a lot in pre-calculus, if you get to calculus, and then even in your college and stuff like that. And pre-calculus next year, most of you are going to be in pre-calc or in college math, and you're going to see this. So it's really important that you do it, okay? This first lesson is nothing technically you've never seen before. We're going to go back to geometry and do everything you've learned in geometry right now, okay? Starting with Pythagorean theorem. But before I start with Pythagorean theorem, I just want to go through how to simplify a radical and how to rationalize the denominator, okay? So it's been a while since we've simplified a radical. So let's do that first, because we're going to do a lot of this, okay? To simplify, if we have something like, let's say the square root of 20, okay? We have a perfect square in there. So we have to find the perfect squares to simplify our radical. And so inside of 20, we could say 20 is 4 times 5, because 4 is the perfect square. And then because 4 is a perfect square, we can take the square root of 4 and we can say this is 2 square root of 5. And 5 is not a perfect square, it doesn't have any perfect squares in it, and so this would be a simplified radical here, okay? And so we would be done with that. And that's simplifying a radical, which we will be doing a lot of. And then we'll also be rationalizing a lot as well, okay? Rationalizing a denominator when there's a radical in the bottom. Okay, so it's going to look something like this. There will be kind of 3 different, I guess, types of rationalizing. So let's say we have something like, or a couple different rationalizing, excuse me. Something like 2 divided by rad 3. Okay, we don't like radicals in the denominator, so we're going to get rid of the radical in the denominator. And so what I want to do is I want to multiply by rad 3 over rad 3. Okay. Again, I'm multiplying by 1. Rad 3 over rad 3 is 1, so it's not really changing anything. But what happens on the top is we get 2 rad 3. Oops. Sorry, hold on a second. Oh, lordy. This is why. Okay, here we go. We get 2 rad 3. And then on the bottom, rad 3 times rad 3, the reason this works is square root of 3 times square root of 3 is square root of 9, and the square root of 9 is 3. And so the radical just completely goes away. And so now you don't have a radical in the denominator, and you are done. You've rationalized everything, okay? Let's see, another example could be something like this. Let's say you have 4 divided by rad 2. Okay, again, you want to rationalize the denominator, and so you're going to multiply by rad 2 over rad 2. On the top, you get 4 rad 2, and then on the bottom, square root of 2 times square root of 2 is just 2. Okay, but then sometimes you can simplify the fraction, okay? Only numbers outside of radicals can be reduced, and if they're inside of radicals, those can be reduced, okay? So like this 2 and this 4, because they're both outside of radicals, can be simplified. 2 goes into 4 2 times, and what we have here is 2 rad 2. Okay, and now that's simplified. So sometimes you might come across, you rationalize something, and then you need to do some simplifying. And then sometimes you might get something like this, like 5 divided by 2 rad 3. Okay. And if you come across something like this, again, you're just multiplying by the radical 3, okay, because that's the only part you need to rationalize. And on the top, you're going to get 5 rad 3. On the bottom, you have the 2, and then it's rad 3 times rad 3 here is 3, because rad 3 times rad 3 again is rad 9, and square root of 9 is 3. And so then you can simplify this, 5 rad 3 over 6. Okay, and again, if I could simplify the 5 and the 6, I would. And so that's rationalizing the denominator. We are going to be simplifying radicals and rationalizing the denominator a lot today. Okay, all right, so let's start. The most basic of our trigonometry is going to be right triangle trigonometry, and we're going to start with the Pythagorean theorem. If you don't remember from geometry, you learn trigonometry. Trigonometry means triangle measurement. Okay, and so that's what we're going to be doing this entire time is triangle measurement. All right, so we start with Pythagorean theorem. We have our formula, hopefully you remember, a squared plus b squared is equal to c squared. Okay, A and B are going to be the legs of the right triangle. Okay, C is going to be the hypotenuse. It will always be the biggest number or the longest side, the hypotenuse, okay? And it doesn't matter which one is A and which one is B. You can interchange those, but C has to be the longest side. It's always opposite the right angle, okay? It's right across from it because it's the biggest angle in the triangle, and so the hypotenuse is the biggest side. Okay, so if you're going to find the missing side, you're just going to use the formula, okay? So in this one, this is going to be my A and my B. You can interchange those, doesn't matter. And then X has to be the C, though. That is the hypotenuse, so it has to be the C. And so it's just going to be 4 squared plus 8 squared is equal to X squared. Make sure you do your order of operations correctly. In PEMDAS, you have to do the exponents before you do any addition subtraction. So that's 16 plus 64 is equal to X squared. Okay, 80 then is equal to X squared. We can add those now. And now since I'm solving for X, I square root both sides. Okay, this is just going to equal X. Okay, square root of X squared is X. We do not have to worry about the positive and the negative when we do this, because usually when we square root both sides, we get a plus and a minus for rad 80, and it's because we're dealing with the length of a triangle. There's no negative lengths, okay? Now, square root of 80, this is what I'm talking about. We need to simplify the radical. There's a perfect square in 80. It's going to be 16. 16 times 5 is what gives you 80. And we can take the square root of 16 here. The square root of 16 is going to be 4. For our rad 5, that's going to be the value of X. Okay. So that is using Pythagorean theorem. We're going to do one more where we have to find the legs. So we have to do a little bit different of math here. And so on this one, I'll call this one my A, this one my B, and then C is going to be the 24. It has to be the 24 because it's the hypotenuse, okay? It doesn't matter A and B, 22 and X. You can rearrange that. That's fine. But C has to be 24. So we get X squared plus 22 squared is equal to 24 squared. Do my exponents. X squared plus 484 is going to be equal to 576. Okay. Now we're solving for X, so I'll subtract the 484 to both sides. And then we get X squared is equal to, I have 92. And now we can square root both sides. Again, we need to simplify that 92. X is going to equal, let's see, 92 is going to be 4 times 23. And the square root of 4 is going to be 2. We cannot take the square root of 23. And so we have our simplified radical. Okay. And so that's solving for a leg in the right triangle. Okay, and that's your Pythagorean theorem. All right, the next part we're going to go to is special right triangles. You learned about these in geometry as well. We had the 45, 45, 90 degree triangle and the 30, 60, 90. I'm going to come over here to the left and talk about the 45, 45, 90 for a little bit. Okay, 45, 45, 90 is an isosceles right triangle. Okay, it's isosceles because you have two angles that are equal to each other. Because those two angles are equal to each other, their opposite sides are equal to each other. Okay, so it's isosceles. Okay, and then you have the hypotenuse, and all of this had a special relationship which you discovered last year. We're not going to discover it. I'm just going to tell you what it is. Okay. And in the 45, 45, 90, if I called each of these a leg, they were the same leg. Like if one had a length of 5, the other one had a length of 5, okay? The hypotenuse here, we said was the leg times the square root of 2, always, okay? So we can figure out different values of a 45, 45, 90 by just using this little formula here. So for instance, again, the legs are both equal, so if I called them both X, okay, the hypotenuse is going to be x times the square root of 2. So I'd call both of these x. So whatever x is, the hypotenuse is x times the square root of 2. So if the lengths of the legs were 5, then the hypotenuse would be 5 root 2. Okay? And that's the easier of the two, the 45, 45, 90. Okay? And then we also have the 30, 60, 90. And this one is going to be a little bit different because now there's 3 pieces to it. And each piece is going to be different because it's a 30, 60, 90. There's no isosceles part of it. So let's say I call this 30 and this 60. Okay. In geometry, you learn that if you have a 30-degree angle, the side opposite is going to be smaller than, let's say, the side opposite the 60-degree angle, because 30 is smaller than 60. Okay. And so in the 30-degree angle, opposite the 30, actually, I'm going to change my color. Opposite the 30, we call it the short leg because it's shorter, okay? And then opposite the 60, we call it the long leg. And then, of course, we have the hypotenuse. It's always opposite the right angle, okay? Well, there's a relationship between all of these, okay? And it's mostly between the short and the long, or the short and the hypotenuse. And it goes that the long leg is always equal to the short leg times the square root of 3. Okay? So it's the short times the square root of 3. So long is equal to the short leg times the square root of 3. Okay? Then the hypotenuse will always be 2 times the short leg. Okay? So the hypotenuse will always equal 2 times the short leg. The short leg will just be the short leg, whatever that value is. Okay? And we can find the long and the hypotenuse based on that short leg. And so if I come over here, and I'll call my short leg x, so opposite the 30 degrees is my short leg, I'm going to call it x. Okay, then my long leg, which is opposite the 60 degrees, okay, is going to be x rad 3. And my hypotenuse, which is always the longest side opposite the right angle, okay, is going to be, it's going to be 2 times x. Okay, so my short leg I'm calling x. My longer leg then is going to be x rad 3, and my hypotenuse will be 2x. And based on all of this, we can find missing pieces of either a 45, 45, 90 or a 30, 60, 90 triangle. So let's do a few examples here. Okay. On number 3 here, so because you see the 45, then you know it's a 45, 45, 90, and the 2 legs are going to be equal to each other because it's isosceles. And so since one leg is 10, the other leg is also going to be 10. So we have x is equal to 10. Now y here is the hypotenuse, okay? And the hypotenuse is going to be equal to the leg times the square root of 2. Well, we said our leg was 10. And that's times square root of 2. So our hypotenuse y is equal to 10 rad 2. And we are done. We have found the leg and the hypotenuse, and we've completed the triangle that we need to find, okay? Over here, now it's going to be a little bit of work. Now, x and y on number 4 here are going to be the same. Again, it's a 45, 45, 90, so these two are equal to each other, x and y. Once we have x, then we have y. So we need to find x. Now, the difference is they've told us the hypotenuse. The hypotenuse is 16. Okay, well, we know the hypotenuse is equal to whatever the leg is times the square root of 2. So let's kind of plug in what we know into this formula, okay? The hypotenuse is 16. The leg, we'll call it x. You could call it y right now. They're both the same. And then it's times the square root of 2. And so we can solve for x. We can divide by root 2 on both sides, okay? And here is where you need to rationalize that denominator, okay? We don't leave it 16 over rad 2. We need to multiply by rad 2 over rad 2. And so that's 16 rad 2 on the top. And square root of 2 times square root of 2 on the bottom is the square root of 4. Square root of 4 is 2. And then simplify a fraction if needed, okay? I don't want that color. 2 goes into 16 8 times. Outside a radical, you can reduce. So I have 8 on the top times the square root of 2 is equal to x. And once you start rationalizing these, you will see that you'll start seeing the patterns, okay? So we have x is 8 rad 2. Remember, x and y were equal because it's isosceles, so y is also 8 rad 2. Okay. And we are done. Those are probably the only different types of problems you're going to get with 45, 45, 90. 30, 60, 90 on the other hand, you'll have, we don't need to do number 5. We'll have a little bit different kinds of problems because there's different formulas, okay? So we don't need to do number 5. I'll throw it in at the very end if you want to listen to it, okay? So number 6 here, what we have is a 30, 60, 90. You can see the 30-degree angle there, okay? So opposite the 30 is going to be my short leg. Opposite what would be the 60 degrees, even though it's not written, it has to be 60. Opposite the 60 is going to be my long leg, and then opposite the 90 will be my hypotenuse, okay? And so we have the value of the hypotenuse. And so what happens is we need to start with the hypotenuse formula. The hypotenuse formula in a 30, 60, 90, it's 2 times the short leg. So let's plug in to what we know. So we know the hypotenuse. So we use the hypotenuse formula. Hypotenuse is 8. That's 2 times the short leg. I can divide by 2 on both sides. And I get 4 is equal to the short leg. And our short leg is x. Okay, so x is equal to 4. So we know x is 4 here. Now that I know the short leg, now I can do the long leg. So you have to start with the number you know. You knew the 8 was the hypotenuse, so that is the formula I used. And so now I can do long leg equals short leg times square root of 3. My long leg is the y value. The short leg was 4, and that's 4 rad 3. And so there we go. We have completed the triangle to find x and y. Okay. Let's go to another one. Number 7 here. Okay. All right. Again, 30, 60, 90 because it shows the 60 degrees. So we have no choice that this is the 30. So the y is going to be the short leg because it's opposite the 30. 27 is going to be the long leg. X will be the hypotenuse, always opposite the right angle. Okay. All right. So again, we only know the information for the long leg. We know it's 27. So we have to start with that formula. We have to start with long leg equals short leg times the square root of 3. Okay? Because that's what we know. So we know the long leg is 27. The short leg we can call y times the square root of 3. And we can solve for y here. We can divide by square root of 3. Giving us the opportunity to rationalize by multiplying by root 3 on both sides, or top and bottom, excuse me. So we have 27 rad 3 on the top, and then root 3 times root 3 is root 9. Root 9 is 3, and that's equal to y. And then always simplify. 3 goes into 27 9 times. So 9 rad 3 is your y value. 9 rad 3. Okay, so notice, yes, I need to find x, but I had to find y first because I only knew the long side information. So I had to use that first. So our y is 9 rad 3. And now we can find our hypotenuse. Do a different color here. Okay, the hypotenuse is always equal to 2 times the short leg. Okay. Hypotenuse is going to be our x. 2 times the short leg is 9 rad 3. If I had not found that short leg, I would have had 2 variables in this equation. So you have no choice but to do what we did first. Okay. So let me finish this. 2 times 9 rad 3. I can multiply the 2 and 9 because they're outside the radical. So that's 18 rad 3. So there's my x value, 18 rad 3. And we are done with that problem, okay? I think I will leave number 8. If you would like to listen at the very end, I will go back and do number 5 and number 8. But for the most part, if you understand those, you should be able to do the homework. Okay, so that's all review of geometry. Now we're going to continue on and review geometry, and now we're going to start our trig functions. Okay, a trig function is a function whose rule is defined by a trig ratio. Okay, a ratio is a fraction, so remember that. A trig ratio will be a fraction. Okay, it compares the lengths of two sides of a triangle. The Greek letter, we are going to be using the Greek letter theta. It's a circle with like a line through it. It's called theta. So you will see that. This is going to represent the angle. Okay? So whenever you see theta, you're going to represent an angle. 30 degrees, 22 degrees, 70 degrees. Okay? That's what the angle is going to be. Okay? And it will be an acute angle in our trig functions because we will be in right triangles, and aside from the 90-degree angle, the other two angles are the acute angles, and we don't do sine, cos, or tan with the right angle. Okay, so sine, cos, or tan, we are going to define this. You defined this last year. Remember opposite and adjacent and hypotenuse and all of those things, okay? And we used, hopefully you learned this, SOHCAHTOA. Hopefully you remember that, SOHCAHTOA, okay? We're going to go through and I'll show you what that means. So, let's say we have this angle theta right here, okay? So, if I say sine of theta, I'm looking from this angle theta specifically, okay? Now, from angle theta, we have opposites, we have adjacent, and we have the hypotenuse. Opposite is going to be this little a. That's opposite. Okay? Adjacent, because it's right next to the angle, it touches it, is going to be this b. That's adjacent. It's right next to. And then c is your hypotenuse. The hypotenuse is always across from the right angle, always. Okay? And so from this angle, you have an opposite piece, you have an adjacent piece, and then you have the hypotenuse. Okay? And so in SOHCAHTOA, the O is the opposite, the A is the adjacent, and the H is your hypotenuse. Okay? And so let's define. Sine is the SO part, the O and the H. Okay? And so sine is by definition the opposite leg over the hypotenuse. In this right triangle here, the opposite we would say is A, and the hypotenuse is C. And so the sine of the angle theta has the ratio A over C. Ratio is just a fraction. Okay. Now cosine in SOHCAHTOA is the ka. So it's defined by being the adjacent over the hypotenuse. Okay, so if I look at my triangle, the adjacent piece is going to be B and the hypotenuse is C. So cosine is going to be the ratio B over C in this triangle. And then tangent in SOHCAHTOA is the opposite over the adjacent. It's the TOA part. So by definition, we have opposite over adjacent. Okay, and in the right triangle we were discussing, the opposite is A and the adjacent is B. And so in that right triangle, the trig ratio of tan theta is A over B. Okay, hopefully you remember that, SOHCAHTOA. Okay, write it down if you need to, as many times if you need to when you're doing the homework. Now you learned that in geometry. I'm going to introduce you to 3 more trig functions that you've never learned before. And that is the cosecant, the secant, and the cotangent. Okay? Now, they're really not that bad. You just need to remember that they are reciprocals and what they're reciprocals of. So the cosecant here, okay, the cosecant is going to be the reciprocal of the sine function. Okay? So cosecant, I know it's confusing because you think cosine, but it's not. Cosecant is a reciprocal of the sine function. So reciprocal means we flip the fraction. So if I flip opposite over hypotenuse, my cosecant is going to be hypotenuse over opposite. In the right triangle we were discussing above, the hypotenuse is C and the opposite was A. And so you'll see here, okay, these two fractions, A over C and C over A, are reciprocals of each other. So once you know one of them, you know the other one. You just need to flip it over, okay? Cosine now is going to be the reciprocal of secant, okay? Cosine and secant are reciprocals of each other, okay? So my secant then by definition is going to be the hypotenuse over the adjacent. Or I could just say for this triangle, if my cosine was B over C, it's going to be C over B, reciprocal of B over C. And then the tangent. The tangent is also going to have a reciprocal called the cotangent. Okay? So cotangent is reciprocal of tangent. And vice versa, by the way. Cotangent is reciprocal of tangent. Tangent is reciprocal of cotangent. Okay? It goes both ways. So cotangent by definition then is going to be the adjacent over the opposite because that's the reciprocal. And in this right triangle we were looking at, the reciprocal of A over B is going to be B over A. Okay. There is no like SOHCAHTOA for this one. Okay, we don't do that for cosecant, secant, cotangent. You just need to remember which one is which for the reciprocal. Okay. All right. So now we're going to find the trig ratios, and you're going to have to find all 6 trig ratios. So the sine, cos, and tan, the cosecant, secant, and cotangent. You will find all 6 of those. Okay. So in this example here, we have a triangle. It has sides 16 and 30, okay? Sometimes you will need to find the third side. So I can find this third side. I'll just call it X. It's my hypotenuse, okay? And so I'll use right triangle Pythagorean theorem to find my third side. If you were in a 30, 60, 90 degree triangle or 45, 45, 90, you could do that. But we don't have any angles in this triangle. We don't know what the measurements are. So that's why we're using Pythagorean theorem. And so I could do 16 squared plus 30 squared is equal to X squared. Okay, 16 squared and 30 squared, 256, and 900, you add that up, you get 1156. That's equal to X squared. And if I square root both sides, this is really nice because the square root of 56 is 34. Okay, so our hypotenuse has a side 34. Okay, all right, now we're ready to find our trig functions, okay? Our angle that we were going to be looking from is this angle theta, okay? And so from that angle theta, okay, we have the 16 is going to be opposite, okay? The 30 will be adjacent, and then we see the 34 is our hypotenuse that we already found. So those are the opposite, the adjacent, the hypotenuse. We're going to use our trig definitions and we'll find the missing pieces, okay? So sine of theta, using our SOHCAHTOA, this is going to be opposite over hypotenuse. Oops. Okay. So O over H, opposite over hypotenuse. Our opposite is 16. Our hypotenuse is 34. And we always reduce our fractions, always. So I can reduce the top and bottom by 2, and we get 8 over 17. Okay. Now, I'm going to go straight into cosecant right now because I know cosecant and sine are reciprocals of each other. So instead of going through the whole process of doing the the hypotenuse over the opposite and doing 34 over 16 and reducing it again, I am simply going to do the reciprocal of 8 over 17, and I'm going to say cosecant is 17 over 8. And I'm done with cosecant. I didn't need to use the definition of hypotenuse over opposite. I just know that it's a reciprocal of sine, so I don't need to go through that whole process, okay? Now let's move on. We'll do cosine. cosine by definition, the ka in SOHCAHTOA is adjacent over hypotenuse. And so the adjacent is going to be 30. The hypotenuse is 34. We can reduce this to 15 over 17. And again, I'm going to go straight into my secant because I know that they are reciprocals of each other. I'm not going to do hypotenuse over adjacent and reduce that fraction. Why do I need to go through all that work when I know I can just flip over 17 over 15 is going to be our secant? Okay. And then we do the tangent. The tangent is going to be opposite over adjacent, so that's going to be 16 over 30. So we get 16 over 30. I'm sorry, I meant to write opposite over adjacent here. That's our TOA. Okay, so 16 over 30, we can reduce this. This reduces to 8 over 15. And again, I can go straight into my cotangent because they are reciprocals of each other. We would get 15 over 8. And we are done with this problem, okay? We found all 6 trig ratios for the specific angle theta in the triangle below, okay? All right, now this one. We have given the ratio of cosine of theta, find the remaining ratios. So what they're saying is they gave us this. They gave us cosine theta is 2/3. We need to find the rest of them, okay? Now, what does this one mean, right? Well, by definition, cosine is the adjacent over the hypotenuse. So in some triangle with an angle theta, I have an adjacent side that's 2 and a hypotenuse that is 3. Let me draw a right triangle. Okay, you can draw it too. And I'm going to put an angle. It doesn't matter where you put your angle. I will put my angle right down here. Okay, that's going to be my angle theta. And from this angle, I have to do the opposite adjacent hypotenuse. It has to be from this angle. Okay, so my angle theta here, the opposite of this angle is going to be this side. The adjacent of the angle will be the one next to it. Okay, and then the hypotenuse is always opposite the right angle. So based on the fact that adjacent over hypotenuse is 2/3, what we're saying is the adjacent is 2 and the hypotenuse is 3 because the cosine is 2/3, okay? And so we need to find our opposite piece, x here, and we will use Pythagorean theorem. X squared plus 2 squared is equal to 3 squared. X squared plus 4 is equal to 9. I can subtract my 4. I get x squared is equal to 5. And when I square root both sides, I get x is equal to the square root of 5. So my opposite side here now has a length of square root of 5. Okay. And we found our entire triangle. Sorry. Okay. We found our entire triangle. So based off the one definition of cosine, I have now found my entire triangle, and I can find all the other trig functions here. So sine of angle theta. Sine of theta is opposite over hypotenuse. So my opposite is root 5. My hypotenuse is 3. Done. Now I can go straight into cosecant. It's going to be the reciprocal of the sine. So I can write 3 divided by root 5. But we have to do a little bit of work, unfortunately. Okay, 3 over root 5 has a radical in the denominator. I need to rationalize. So I got to get that radical out of the denominator. I multiply by root 5 top and bottom. And I get 3 root 5 over 5. Okay. So sometimes you flip it over and then you have to do some work, unfortunately, okay? Cosine already given to us, so the secant is going to be the reciprocal, and we get 3/2. Great, we don't have to do anything there, it's just 3/2. If I can write the number 3. Still can't write the number 3. 3, thank you. Okay, and then tangent, opposite over adjacent. So the opposite is going to be root 5. And the adjacent was going to be 2, so we are done with that. We flip it over to find the cotangent, 2 divided by root 5. Again, we have to rationalize, so I multiply by root 5 over root 5. And we get the cotangent is going to be 2 root 5 divided by 5. Root 5 times root 5 is just 5. Okay? And we have completed this problem. Oh, Lordy, you guys know that's a 5, right? 5. Thank you. Okay. All right. So that's what we're going to do for SOHCAHTOA. And now the last part of this is going to be finding trig ratios of special right triangles, okay? The angles of 30, 60, and 45 degrees are used a lot in trig, and when we learn the unit circle, you will see how much we use them, okay? So we can use our knowledge of what 45, 45, 90 degree, and 30, 60, 90, the relationships of those sides to find trig values, okay? So above, when we learned 45, 45, 90, we learned that the sides were equal, and so if I called this side x, I could call this side x. And then we also learned that the hypotenuse was the leg times the square root of 2, so we said, oh, okay, then this is x times the square root of 2, okay? So it's whatever the leg is times the square root of 2. Well, we can use this information to find the trig ratio for sine 45, for instance, okay? So like right here, sine of 45 degrees. Sine is going to be opposite over hypotenuse. It doesn't matter which 45 degree angle you use because it's isosceles. This is just a special case, okay? So the opposite of a 45 degree angle, whichever one you use, will be x. The hypotenuse is going to be x rad 2, okay? And now you can do some simplifying. X divided by x is just 1, okay? And so we are left with 1 divided by rad 2. Always rationalize, so I multiply by rad 2 over rad 2. And what we get on top is 1 times rad 2 is rad 2, and on the bottom, 2. And so the sine of 45 degrees is the square root of 2 over 2. Now what I want you to notice is it doesn't matter what the length of x is. The length could be 10, the length could be 5, the length could be 72, okay? The sine of 45 degrees will always have a ratio of the square root of 2 over 2, always. That's how trigonometry works. That's how triangles work, okay? Because of the specific angle of 45 degrees, the sine of that angle, the opposite over the hypotenuse, that trig ratio, will always be square root of 2 over 2, always, okay? Now the cosine, cosine of 45 degrees, okay? Cosine of 45, we look at the triangle is going to be the adjacent over the hypotenuse for cosine, okay? And again, it doesn't matter which 45 degree angle because they're both the same. The adjacent side is x and the hypotenuse is x over root 2. Or excuse me, not x over root 2, x root 2. Hopefully you notice it is the same exact thing as sine of 45 because it happens to be isosceles, right? So you get the 1 over rad 2. You can rationalize it. You multiply by rad 2 over rad 2, and you get square root of 2 over, not 4, over 2. Square root of 2 times square root of 2 is 2. Okay, so sine of 45, cosine of 45. Doesn't matter what the lengths of that x is, it will always be rad 2 over 2. Okay. And then the last one, tangent 45 degrees. Tangent by definition is opposite over adjacent. And so opposite over adjacent, again, if you're looking at the bottom 45 degrees, the opposite is x, the adjacent is x, okay? And so we would have x over x divided by x is just 1. Tangent of 45 degrees will always be 1. If my side length, let's say x was 1,000, 1,000 divided by 1,000 is just 1. Tangent of 45 will always be 1 because it's always going to have that ratio in a 45, 45, 90 degree triangle. Okay? All right, now on to the 30, 60, 90. These ones are a little bit different, again, because the 30 and the 60 are not the same. Okay, it's not an isosceles. So in a 30, 60, 90, we started always with the short leg. Okay? Opposite the 30 degrees is going to be your short leg. And I can call that x. And then opposite the 60 degrees is your long leg. And your long leg is always the short leg times the square root of 3. And so your long leg here is going to be x rad 3. Short leg times the square root of 3, x rad 3. And then the hypotenuse was always 2 times the short leg. And so in this case, the short leg is x, so your hypotenuse is 2x. So you have x rad 3, and you have 2x, okay? So let's find the sine, cos, and tan of 30 degrees, okay? That's what we're going to do first, sine, cos, and tan of 30 degrees. Because you're doing it of 30 degrees, you have to look from this angle. For the 30 degrees, the opposite is going to be this x. The adjacent will be the x rad 3, and the hypotenuse is always the hypotenuse, okay? So it has to be from the 30 degrees because we are finding sine of 30 degrees, cosine 30 degrees, tangent of 30 degrees, okay? So the sine of 30 degrees is going to be the opposite over the hypotenuse, that's x over 2x. Okay, always reduce. I can reduce x into 2x. That's going to be 1, and we get 1/2. The sine of 30 degrees, no matter what size that triangle is. It could have lengths of like 10 and 20 and whatever, but the sine of 30 degrees will always be 1/2. Okay, the cosine of 30 degrees. Oh, did I write hypotenuse there? I am sorry. This was supposed to be adjacent. I'm talking and writing, and I didn't write it right. This is supposed to be the adjacent. My bad. You're probably confused by that. Opposite the 30 is the x. Adjacent is the x root 3. Hypotenuse is 2x. My bad. Okay, so going back to cosine 30 is adjacent over hypotenuse. Cosine by definition, adjacent over a hypotenuse. SOHCAHTOA, right? So adjacent is x root 3. Hypotenuse is 2x. So we have x root 3 over 2x. I can cross those x's off because x divided by x is 1, and we have root 3 on the top, 2 on the bottom. And so cosine of 30 degrees will always be the square root of 3 over 2, no matter how big the triangle is. Okay? And now the tangent. Tangent of 30 degrees is the opposite over the adjacent, okay? The opposite of the 30 degrees was the x. Oh, come on. And the adjacent to the 30 degrees was the x rad 3. Let's simplify. X divided by x is 1, so we have 1 divided by rad 3. We do not like radicals in the denominator. We rationalize. Multiply by rad 3 over rad 3, and we get rad 3 on top, and then square root of 3 times square root of 3 is the square root of 9, which is 3. And so tangent of 30 degrees will always be rad 3 over 3. Okay? So that's from the 30-degree angle. The last thing we're going to do is find the sine, cos, and tan from the 60-degree angle. So what happens now is my adjacent and my opposite are going to switch. I'm looking from the 60-degree angle. And so from the 60-degree angle now, the opposite now happens to be the x rad 3, and the adjacent is the x. We've switched them because now we are looking from the 60-degree angle, okay? Hypotenuse is always the hypotenuse, always, okay? So when I find the sine of 60 degrees, my opposite is now x rad 3, and my hypotenuse is 2x. Okay, I can simplify. X's cancel, and I'm left with rad 3 over 2. Okay. Sine of 60 degrees will always be square root of 3 over 2, no matter the length of x, always. Also notice cosine of 30 is the sine of 60. That's because they are complementary angles. This kind of always happens. We'll talk more about this later on in the sections, okay? But notice cos of 30 is the same as sine of 60. That always happens. Just little things you'll start noticing as we're working through these problems, okay? So cosine of 60, adjacent over hypotenuse. The adjacent is x, the hypotenuse is 2x. So we have x over 2x, and just like above, the x's cancel. We're left with 1 on the top, so it's 1/2. Okay, cosine of 60 will always be 1/2. Notice the sine of 30 and the cosine of 60 are the same. Okay, always happens. And then finally, the tangent of 60, okay? Tangent of 60 is the opposite over the adjacent. The opposite side was going to be x rad 3. The adjacent side was going to be x. So we can cancel those, and all we're left with is rad 3. We don't have to rationalize that. There's nothing in the denominator. It is done, okay? Notice that tangent of 30 and tangent of 60, these two here, okay, are reciprocals, okay? That always happens as well. So there's little tips and tricks you'll see and patterns you'll see as you move along. They're all related to each other, okay? I know that was a long lesson. Thanks for sticking with me. If you understand it, you're good to go. I'm going to go back up really quick and do numbers 5 and 7. If you would like to listen, you may. If not, you are done. Thank you and have a great day. Okay. So going back to number 5, we are in a 45, 45, 90. So that means x and y are the same. And this is my hypotenuse. And the formula goes, the hypotenuse is equal to the leg times the square root of 2. So let's plug in everything we know. Hypotenuse is 14 rad 2. The leg, you can use x or y. It doesn't matter which. They are both the same. I will use x, rad 2. And then I will divide by square root of 2 to solve for x. That goes away. And then on the other side, it ends up that square root of 2 divided by square root of 2 also cancels, and we're just left with 14 is equal to x. So my x is 14. Because it's isosceles in a 45, 45, 90, my y is also 14. Okay, that's number 5. And then number 7, now we're going to the 30, 60, 90. So even though it's not written, this angle is 30. Opposite the 30 is always your short leg, okay? Opposite the 60 is your long leg, and then x here is your hypotenuse. It's always across from the right angle, okay? So we have the short leg. We can start with the longer, the hypotenuse. This is the only time you can pick which one, okay? I'll start with the long. The long leg equals the short leg times the square root of 3. So my long leg is y. My short leg is 5 rad 6, and then I got to multiply that times rad 3. Okay, I'm going to do a little bit of work here. This is going to be 5 square root of 3 times square root of 6 is the square root of 18. I can multiply those because they are both in radicals. And then I'm going to simplify rad 18 because it has a perfect square in it. Square root of 18 is going to be 9 times 2. Okay, and the square root of 9 is 3, so I have 5. When I take the square root of 9 here, square root of 9 is 3, gets multiplied to the 5, and I can't take the square root of 2. So this becomes 15 rad 2. Okay, and that's our y value, 15 rad 2. Okay, now for the hypotenuse. Okay, hypotenuse is 2 times the short. So hypotenuse x is going to be 2 times the short leg, which is 5 rad 6. Okay. And we can just multiply 2 times 5. They're both outside of radicals. We get 10, and then times the rad 6. So this is 10 rad 6. Oops, a little bit better. And we are done. We have completed all the problems. If you stuck with me, great. Thank you. I know this is hard. Do the best you can, and I'll be in my Zoom so you can ask questions. You have a lesson 1 homework assignment or a worksheet that you need to complete, all of it. Let me know if you have any questions. Have a great day. Miss you all. Goodbye.